Hi guys, I will be doing the solutions for previous year quant questions in a short video series. I'll do 6 questions per video, hoping to do 1 or 2 videos a day. Starting with CAT 21 because after that paper was released, I did a small thing where I tried to tag questions at concept level, at general problem solving principle level, and things that you can do to become faster, the speed math trainable elements within a question. um, I'm planning on doing 25 next, most recent cat. I will make a separate video talking a little more detail about this, what is the purpose behind this, what are the objectives, uh, prior version and its limitations, and why I discarded it. I don't want to waste people's time with that nonsense. For the people who are not interested in that, I'll just get into the questions for the time being and we will explain in detail. What I'm trying to do differently is I will try to give you optimal solutions that toppers are using to actually finish the paper. All sites, all coaching institutes have these questions and these solutions. The problem is that the methods that they give you are easy to understand, and usually if you use those methods you will not be able to do 22 questions in 40 minutes. um, the toppers who run those institutes are not using the same methods. That is the thing that hopefully you'll take away from this. And these better methods, unfortunately, will take you more time to master, but you have to put in that effort to learn these better techniques, to be able to try to finish the section within the allotted time. That is the purpose of this, primary purpose of this. I was also trying to find out what they're testing. I don't know to what extent I've succeeded in finding that, but I now have some tags that I will explain. Hopefully you'll get a better understanding of uh, how these people make these questions, what are they trying to test, what could you be learning that you're currently missing, all those things. So yeah, I'm aware that solutions are available. This is a slightly different take. Hopefully somebody will find some value out of it. Let's look at the questions. Question 1. Fx is equal to x square plus 2x minus 15 by x square minus 7x minus 18 is negative if and only if, and the options are solution ranges. So this is just an indirect way of saying x square plus 2x minus 15 by x square minus 7x minus 18 less than 0. Solve this quadratic inequality. That's what the question is. So the concept is quadratic inequality, but I want you to understand that let's do this with the most optimizations. What an expert solver will do when they get this, uh, if they've really mastered the concept of the applications and they've done the practice, they're going to say that this is basically x plus 5 into x minus 3. They're not going to need any much time to do that. And this is actually x minus 9 into x plus 2, and you'll directly just put it here, x minus 9 into x plus 2 less than 0. And the concept is, I will explain this, I will explain the missing links here in more detail, but I want you to understand what I'm trying to do here. So you have your minus 5, minus 2, 3 and 9, and then you have your plus minus plus minus plus, and because it's less than 0, this is the range that these are the ranges that we're looking for, and the answer would be minus 5 to minus 2 union 3 to 9, and that would be the answer. So if you really know your stuff, this is all you need to do. And so let's explain this for the people who might not know the concept or the optimizations involved. When you have a quadratic inequality, okay, let's get this part out first. Let's get this out of the way first. Uh, that is why I've written factorizing a quadratic as a skill that could make you solve faster. What is the speed trainable element here is converting this to this instantly and this to this instantly, and this is pretty easy to do for any quadratic where the coefficient of the x square term is 1. Understand that usually these are made in a way that's factorizable. They're not just gonna randomly write a 7 and a 15 here. The questions are made with the answers in mind. Somebody expanded this and made this. That is usually what happens in a competitive exam, and you'll see this over and over again. Fine-tuned question values that make for easier calculations afterwards. And so what's happening here, I mean, a lot of people who are watching this would know this, but this is for the benefit of the people who don't. We have a sum and a product, right? So typically when we learn this for the first time in 9th standard or whatnot, you will be thinking of it as sum is equal to plus 2 and product is equal to minus 15. There's a small hack, a small change to this that I can recommend for practical calculation purposes. It is that whenever I see a minus here, instead of sum I think of difference. Why is that? Because we are talking about a negative product, which means you have a negative number into a positive number. That's the way you get a negative product. And so you have a negative magnitude and a positive magnitude being added. That is essentially a subtraction, right? So whenever you see something like this with a minus here, think difference instead of product. So and ignore the sign here. And so you're just looking for two numbers with a difference of 2, whose product is 15, numbers of 3 and 5. And for their net to be positive, the bigger magnitude has to be positive and the smaller magnitude has to be negative. And that is all there is to it. Right? You can do that instantly. So if I were to give you something like x square plus 3x minus 40, let's say 42, you'll just think, no way, wait, let me just, x square plus 3x minus 54, right? You'll just think two numbers with a difference of 3 whose product is 54, so that's going to be x plus 9 to x minus 6 plus 3 sum, product is minus 54, right? Kind of trivial to a lot of people who are going to be watching this, but to those who are not, if you can practice this a little bit, that's the only part here where you might be lagging behind somebody else who's solving this question. So that's a speed trainable element to this question. So that's the first part. Let's get rid of this first. The second thing is the concept here. The concept here is that if you are doing this from scratch, first time you learn quadratic inequalities, you would first do the factorization. Okay, we have our x plus 5 into x minus 3 divided by x minus 9 into x plus 2 is less than 0 is what would happen when you factorize this and factorize this. This is where the actual concept is coming in. What we are told to do in this situation is very simple. Whenever you have a quadratic inequality like this, first you have to ensure that this side is 0, and I'll explain why as we proceed. Let's move this a little further. Okay. Give me a sec. What you're told to do, the problem with inequalities as opposed to equations is you cannot just willy-nilly not transpose. You cannot just cross multiply any term, right? If you had a 5 here, for example, you could cross multiply it, it's fine. Even if you had a minus 5 here, you would cross multiply, but then you will flip this sign. The situation with inequalities as opposed to equations is that if the thing that you're cross multiplying is positive, don't flip the sign. If it is negative, do flip the sign. This is what we know about the concept. Now, that means if you have an expression where it is not known whether it is positive or negative, you do not know whether you have to flip the sign or not. That is a problem that we face. The resolution of this problem is to say, instead of x plus 2, and what is cross multiplication basically? Cross multiplication is basically, let's say I wanted to cross multiply this x plus 2. What I'm doing is I'm multiplying both sides by x plus 2. This is essentially what's happening, and then you could cut this. That's what cross multiplication is. Now the issue is, as I said, in inequalities, you cannot multiply the same thing on both sides unless you know whether that quantity is positive or negative. If it is positive, no flip. If it is positive, there is a flip. There is a sign flip. So that's why cross multiplication like this doesn't work. But the resolution is, you can, instead of multiplying both sides by x plus 2, you could multiply both sides by x plus 2 whole square. Now x plus 2 whole square is an even power, and therefore it cannot be negative. Generally it is either 0 or positive, But in this situation, understand that x plus 2 is in the denominator here. As soon as this question was presented to you, x plus 2 equal to 0 has been negated. It is not possible, because then this expression is not defined because of division by 0. So at the very outset, x plus 2 is not equal to 0, which means that x plus 2 whole square is necessarily positive. Now that we know that it's positive, we don't need to worry about flipping the sign, and so you can throw them on either side of the inequation. After that, you can cut one of the x plus 2's with the one in the denominator. For the LHS, for the RHS, what happens? It's being multiplied with 0, so it really doesn't do anything, right? And you can do the same thing with the x minus 9 whole square on both sides. It's the detailed concept of what's happening. And then you can cut one of them with this, and the other side again being multiplied by 0, it doesn't really do anything. And so after you do this, what has happened? The two brackets that were there in the denominator have now moved to the numerator. And so then your next step will be x minus 9 into x plus 2 into x plus 5 into x minus 3 is less than 0. This is the formal way of writing the solution to this, all the steps. But you don't need to do it beyond the first time you ever do a quadratic inequality with the denominator. You know exactly how it's gonna play out. You are gonna say I'm gonna put even power on both sides, and then because on the RHS, because it's being multiplied with a 0, it's not really doing anything, which is the reason why, as I said at the beginning, you have to ensure that one side is 0 before you do all of this. Now, as somebody who has done this a couple of times, you would know that this is what's going to happen. What's going to happen is what was in the denominator will turn up in the numerator. And somebody with experience will look at this and combine their ability to factorize quickly without paper and their knowledge of how this step will progress, and they will directly write this. And from there, what happens? The next part of the concept is that the product is 0. The product is negative if you have an odd number of negative terms, right? Let's talk about this in a little more detail as well. If you look at any value that's greater than 9, this is the number line for the one variable x that we have here. If you think about this region to the right of this 9, let's say 10 as an example, you will notice that 10 minus 9 is plus 1, positive. 10 plus 2 is 12, positive. 15, positive. 7, positive. And so you have 4 positive terms, their product is going to be positive. So for every value of x beyond this, the expression is going to be positive. But when you jump from here to here, you'll notice some value between 3 and 9, let's say 8. You will notice that 8 minus 9 is negative. 8 plus 2 is positive, positive, positive. So you're going to have negative into positive into positive into positive, which is going to be a negative product. So between 3 and 9, the expression is going to be negative. But when you go here, let's say 2.5, you will see that this is negative, x minus 3 is negative, x minus 9 is negative. These two are positive. The product is going to be positive. So it kind of alternates. The rightmost region will be plus, and after that it just alternates. This is again something that you learn when you practice this. You do a few questions, you will not have to reason it out in 100 words like I did over 1 minute. You will just put a plus at the right end and it will just alternate, right? And what are we looking for? We are looking for negative values. Negative values would be between 3 and 9 and between minus 5 and minus 2, which is option A. So that's the question. The concept is you have something with the denominator. You have to make sure that the other side is 0, which it already is. You have to factorize, then use this particular technique to put what was in the denominator and move it to take what was in the denominator and move it to the numerator. Now you have a quadratic inequality. Technically, this is the thing that we call a quadratic inequality. So you can say reducible to quadratic. So that's the point of the comment column for each idea here. And then you solve it. This is a standard concept that we know. When we solve it, we choose the right option, and that's done. That's the first question. Let's look at the second question. Second question is saying the number of integers n that satisfy the inequalities mod n minus 60 less than mod n minus 100 less than mod n minus 20 is. How many integer solutions are there? The options are kind of stupid because they're all near 20. Uh, if I had said this, I would have maybe put 1920 and 3940 or something just for fun. We'll talk about it. But the best way to solve this is graphically. I've written it here. I could write it here as well. What we're dealing with is inequalities with a modulus. That's an inequality, and there is a modulus symbol. That's a separate subtopic when we learn inequalities. And then as a general problem solving tool, I've mentioned graphs, modulus. Let's look at this. What would I do with whatever knowledge I have and whatever expertise I have? If I see this, I will just graph this immediately like this. I will have my number line. I will put down my 20, 60 and 100. So let's say 20, 60 and 100 like this. And my mod n minus 20 graph, just to draw it easily with my paint tools, I'm gonna prefer to just take this. This is easier. Mod n minus 20 is gonna look like this. Forgive the, oh my god, let's just it is gonna be a V shape and it's gonna be shifted right from n is equal to 0. I'll explain in more detail after I solve this, and then I'll have my mod n minus 60 here, and I'll have my mod n minus 100 here. The difference between 20 and 60 is 40. 60 and 100 is also 40. So we can separately plot these three things. They will all be V-shaped. You understand that this is extending infinitely. I'm just choosing to draw a little bit. They're all going to be V-shaped. Additional information, this will have a slope of -1, this segment will have a slope of +1. So it's a graph that goes -1, +1 slope, which I don't think we need for this question. What they're asking is that the n minus 60 curve should be below the n minus 100 curve, which happens where? Notice that after this point, n minus 60 value is above the n minus 100 value. So, and where is this? This is going to be 80. Beyond 80, the n minus 60 curve is above and the mod n minus 100 curve is below. We don't want that. This and at 80 they're equal. So below 80 is where we have the favorable region. So that was for this part. And then you look at this part. The n minus 100 curve should be below the n minus 20 curve. Notice that after this point, n minus 100 curve is above and n minus 20 curve is below. I keep saying n minus 20, but I mean mod n minus 20. But to the right side of this point, mod n minus 20 curve is above and the mod n minus 100 curve is below. And at 60 they're equal, so we'll discount 60 as well. So this doesn't work for us. This works for us. So to satisfy this inequality and this inequality simultaneously, we are looking for the region between 60 and 80, but not counting the endpoints. Just basically 61 to 79, which is 19 terms. The thing to remember here, small trap is there in the question. 20 is also given as an option. 20, 18, 21, everything is given, right? When you're counting 61 to 79, the number of integers you have is not equal to 79 minus 61. Because you're counting both endpoints, you will have to do a +1. Just as something that you have to remember. 1 to 10, there are 10 numbers. If you ask anybody, they'll say there are 10 numbers. If you ask 10 to 20, they will, funnily enough, they'll still say there are 10 numbers between 10 and 20. Whereas actually there are 11 numbers, right? So if you're counting from one end to another end, both ends included, you do a +1. So you'll have 19 numbers. 19 integer values of n for which the inequality holds yet another inequality question, inequality with a modulus. Best way to solve this is using graphs. That's question number 2. Let's move on to question number 3. I think I should clarify a little more about this. Okay, something to add here for question 2. How do I draw those graphs to begin with? So if I have y is equal to mod x, that is quite simply this. There's nothing to reach there. You just have to know this. Y is equal to x would have looked like this, right? Y is equal to mod x would instead look like this. It drops down and then rises up, slopes of -1 and +1. What if I wanted y is equal to mod of x minus 20? You are adding a constant here, right, to the input. So minus 20 will make you shift right by 20 units. And so that will be, if 20 is here, you will have a V shape like this. This will pass through 0, 20. And it's basically shifting right by 20 units. That's the shifting concept in graphs. Could probably add that there, graphs shifting and modulus. So that's how I quickly drew these. So if your 0 is here, your x mod x minus 20 is basically y is equal to mod x right shifted by 20 units. Mod x minus 60 is right shifted by 60 units. Mod x minus 100 is right shifted by 100 units. That's basically what we have, and the rest we have already explained. That is question number 2. Let's move on to question number 3. Now I'm going to do something that will feel more efficient than what you probably did. I'll do it first and then I'll explain. Identical chocolate pieces are sold in boxes of 2 sizes, small and large. The large box is twice the price of the small box. If the selling price per gram of chocolate in the large box is 12% less than that in the small box, then the percentage by which the weight of chocolate in the large box exceeds that in the small box is equal to what? Is nearest to what? Cool. So basically, if I get a question like this, I'll be like price equal to rate into quantity. The price of the large box is 2 times that of the small box. The rate of the large box is 12% less. 12% less is 88% off. We are trying to find the weight of the large box in terms of the weight of the small box. By what percent does it exceed? You can just cross multiply this and you can say Q is equal to 200 by 88. Take out an 8, it's 25 by 11. And this is basically 227.27% off. That means that the large box is 227 the weight of the large box is 227% of the weight of the small box, which is the same as saying 127% more than the weight of the small box. And that's all you have to do to solve this question. You don't need to assume unnecessary values. Just go to the crux of it, take the 2 and the minus 12% and find the plus 127%. That is all you have to do. I'll explain this in a little more detail. So price is equal to rate into quantity is ubiquitous in the entire arithmetic unit. What we're basically trying to say is that the selling price is equal to the selling price per gram into the number of grams, which nobody is going to disagree with. But the thing is, in these kind of situations, you want to understand that this is true for the large box. SP of the large box is SP per gram of the large box into number of grams in the large box. And SP of the small box is SP per gram of the small box into number of grams in the small box. And then you can take these two equations and divide one with the other, which gives us the price ratio is equal to the rate ratio into the quantity ratio, which is what I started with. I'm not going to write this down over and over again. I know this already. So I'm just going to use it straight up. And what is given to us? The large box, SP of the large box is twice that of the small box. This is given to us as 2. The SP per gram of the chocolate in the last box is 12% less. This is 12% less than this. When you divide it, you should get 88 by 100. Just remove all the fluff. Just do the bare minimum. Into whatever this ratio is, this is the unknown. I'm going to try to find it. And then I get this is 25 by 11. And that means, see, understand that you can do this two ways. Either you will convert this fraction into a percentage, and that's where this turns up, fraction decimal table. If you by heart this, there are a few more things. I guess I guess I could add division, basic division. Not worth adding. Okay, you should necessarily by heart the decimal equivalent of all fractions up till 11 by 12. So I'm saying 1 by 2, 1 by 3, 2 by 3, 1 by 4, 2 by 4, 3 by 4, all the way up till 1 by 11, 2 by 11, till, sorry, did I say 11? 12. 1 by 12, 2 by 12, up to 11 by 12. Bare minimum you should by heart this because it will save you a lot of time. So, either you can look at this 25 by 11, and that's 2 and 3 by 11, which I have by hearted is 2.27. And then this is percentage off, right? The heavy box, the large box is 2.27 times the small box, or 227% of the small box, which is 127% more than the small box. Alternately, you can just subtract a 1 from here first and say 14 by 11 more, which is 127% more. It doesn't really make a difference. But the thing is, you should know that 3 by 11 is 27.27% by heart. You don't want to throw this into the on-screen calculator and find out, because that is where you are going to lag behind the competition. So this the only speed trainable aspect here is to know this calculation by heart. At least the remainder part of this 25 by 11 is actually 2 and 3 by 11. Converting this to 0.2727 is the only part that is speed trainable. The rest is the concept. Invariance is when you divide one equation. Usually one version of invariance is when you divide one equation with another and you get a ratio equation. The price ratio is equal to the rate ratio into the quantity ratio. That is all you need, and that is all you can find. If you ask me what is the price of the large box, or let's say you ask me the weight of the large box, cannot find. Weight of the small box, cannot find. What is the ratio of these two values? That is something that you can find, right? The answer is invariant of the actual weights and prices. It depends only on the ratio. That is the idea. This is a general idea that you will see across chapters. This, I would say, is the part where you can speed up your solution after you have the most optimal algorithm. So that's question number 3. Let's look at question 4. 4 doesn't really have any optimizations. You just have to do it the boring way that you'll do it in school itself. Your school solution doesn't really differ from your competitive exam solution. You just have to do it properly. Question 4. What do you have? If 5 minus log to the base 10 of root 1 plus x plus 4 log to the base 10 of root 1 minus x is equal to log to the base 10 of 1 by root 1 minus x square, then 100x is how much? Now the tags that I've written here are logarithmic identities and algebraic identities, which you would think, right, if you have a 1 plus x and a 1 minus x and you also have 1 minus x square, there's something to be done with that, right? We know that 1 plus x into 1 minus x is equal to 1 minus x square. That is likely to turn up and be relevant at some point in the solution. So what do? Unfortunately, this is a -1 coefficient and a +4 coefficient. That's not going to gel well for us. If this had been +1 instead, I could have combined this and made it a, I guess, root 1. Yeah, it doesn't really matter. If this was also -1, I could probably have combined it and said, log root of 1 minus x square. That's not going to happen. So what do? What you can do is you can take this and transpose it to the other side, and you will end up with 5 plus 4 log to the base 10 root 1 minus x. On the LHS, on the RHS, you have log to the base 10 1 by root 1 minus x square plus log to the base 10 root 1 plus x. Now you have a log a plus log b situation. That's a known logarithmic identity, and so you can make that log of root 1 plus x divided by root 1 minus x square, which is just gonna be log of 1 by root 1 minus x, because this is 1 minus x into 1 plus x, and the 1 plus x part would cut to the part in the numerator. Now this can actually be written as minus log root 1 minus x. That is another identity that we know. Log 1 by x is equal to minus of log x, right? Removing the negative is equivalent to taking the reciprocal of the argument. So now that we have that, let me just copy this. Now you can transpose this log term here and this 5 term here, I guess. What does that give us? Notice that this term is the same as this term, so it's just going to be a plus 4 here and a minus 1 here. The minus 1 goes here and is converted to a plus 1. So you'll end up with a 5 log to the base 10 root 1 minus x is equal to minus 5. You can cut the 5 from both sides. You are getting log root 1 minus x to the base 10 is minus 1. I guess you can replace this minus 1 with a log of 1 by 10. That will make it easier for us. Minus 1 is just log of 10 raised to minus 1, which is 1 by 10. At which point, I guess you can remove the logs from both sides. Taking anti-log on both sides, you will get root of 1 minus x is equal to 1 by 10. Just gonna scroll down a bit. This gives you 1 minus x is equal to 1 by 100. Transpose both the x and the 1 by 100, you will get x is equal to 1 minus 1 by 100, which is 99 by 100. They're asking for what? They're asking 100x. 100x is equal to 99. Straightforward question, straightforward method. I don't have any hacks, any unconventional solutions. Just do this straight up. What did we have? We had a few logarithmic identities. We had log a plus log b here. We had the algebraic identity. This is the only bit. Converting this to this is the only part that can be tagged as algebraic identity. The rest is just log identities. Just transposition, identifying similar terms, putting them on the same side, cutting coefficients which are similar, then taking anti-log on both sides. That is the other log concept there. Then again more transposition, cross multiplication until you get the answer. Nothing fancy here, nothing additional to provide, just the two concepts. That's question 4. Let's move on to question 5. Oh my god, what have I written here? Unknown ratio, 2 equation, 3 variables. A very important concept to know. I'm wondering if I should explain it upfront. I don't need to. To solve this question, you don't need to know this. Okay, let's talk about this. They are saying a basket of 2 apples. If you assume the cost of 1 apple is A rupees, the cost of 2 apples would be 2A rupees. So this basket contains 2 apples, 4 oranges, and 6 mangoes. And this would be the cost of that basket. They're saying it costs the same as another basket with 1 apple, 4 orange, and 8 mangoes. And these two have the same cost as a third basket with 8 oranges and 7 mangoes. Then the number of mangoes in a basket of mangoes that has the same cost as the other baskets. So we want a fourth basket that contains only mangoes and nothing else. which should cost the same as these three baskets. How many mangoes are in there is basically the question. Um, Now, technically, you don't need to know this concept to solve this question, but it's still worth discussing. It's a very useful concept, it keeps turning up. Let's talk about this. So, at its very simplest level, if I gave you y is equal to x, just the one equation, two variables, and I asked you to resolve this, which means I need a unique value of y and a unique value of x, you would not be able to do that because it's one equation, two variables. That's not possible. But if I rewrite this as y by x is equal to 2 by 1, notice that this information is sufficient to find the ratio of two terms. So the concept is that the ratio of two terms, unknown ratio of two terms, is basically one unknown. The value y by x, which is equal to 2 by 1, this one value is the only unknown here as far as the ratio is concerned. If you separately ask me what is y and what is x, that's a different issue. That's two unknowns and you need two equations to solve them. So for example, if I also gave you y plus x is equal to 9, then you would say y is 6 and x is 3. Unique resolution. That's equation 1, equation 2. So we encounter situations like this where there is a separate sum equation and the rest of it helps us find the ratio, and becomes this concept, this idea becomes clearer if you look at three variables. Let's say I have y is equal to 2x and z is equal to 3y. That's two equations in three variables. If I asked you to give me the unique values of x, y and z, you cannot do that. Two equations in three variables is not resolvable. You can't find unique values. But this is actually sufficient. 3y can be written as 2x, right? This is actually enough to find the ratio of x's to y's to z. Traditionally, we will say just equate it to k and then write k by 3, k by 2 and all. But I would just say, from a practical exam, competitive exam point of view, look at the coefficients, take the LCM. Just put 6. LCM of the coefficients 1, 3, 2 is 6. And then you can say that x3, y2, z6 would satisfy. So the ratio, the unknown ratio, x's to y's to z, is 3 to 2 to 6, and it can be found from two equations because the ratio x's to y's to z is just two unknowns. It's not three unknowns. The exact values of x, y, z are three unknowns. How is that relevant? If I have three equations, let me just remove this part. If I have three equations, y is equal to x, z is equal to 3y, and x plus y plus z is equal to 44. You don't want to solve this from a competitive exam point of view. You don't want to solve this as three equations in three variables the way we traditionally do simultaneous equations. You want to identify the fact that two equations in three unknowns is sufficient to resolve the ratio and find the unknown ratio of three terms. Two equations are sufficient, and then once you have the ratio, you combine it with the sum and solve this. So you have your what is it, 3 is to 2 is to 6, was it 3 is to, wait, did I get this right? Z is, I may have gotten this ratio wrong. Anyway, this 6 would be 2 would be 1. I think 6 is 2 is to 1. I messed up the final ratio. Let's say I have what would this be? If I put 6, I'll have 2. If I put 2, I'll have 1. So I have 6 is to 2 is to 1, right? Yeah, if I have 45, I would find the 6 is 2 is to 1 first, and then say 9 parts is 45, and then find the values of x, y, z. I messed up the example a little bit, but the idea is, if you have a situation like this, you want to use this to find the ratio first, and that's usually more efficient. It also lends itself better to paperless solving if you want to do that. That's the concept here. You don't really need this concept to solve this question, but it's a useful concept to know. It's the closest tag I could find. But anyways, let's get back to the actual question. uh, what we have is one equation, another equation, right? Let me just move this a little bit. I have my equation number 1 and I have my equation number 2. You don't want to then equate this and this because that information is redundant. You already have it in equation 1 and 2. So you just have two equations. You don't, more importantly, you don't have a constant number. If you had a plus 7 rupees, this wouldn't work. But all you have are first degree terms. They're all first degree terms, no 0 degree terms. This should work fine. You can use these two equations to find the ratio of the cost of an apple, orange and mango. Anyways, what you want to do is you want to take the first part and you want to cancel out the 4 O's on both sides and then transpose the A to this side and the M to this side. Isolate the A terms and the M terms and you will get A is equal to M. And you could then just take that. Is it A is equal to 2M? A is equal to 2M is correct. Yes. If you take that and substitute it either here or here, what are you going to get? Let's say you substitute it here. Instead of 1A, you will have 2M. And so the equation is now 2M plus 8M is 10M. 10M plus 4O is on the LHS. On the RHS, you have 8O plus 7M. Again, you isolate the M terms and the O terms. You would have 3M is equal to 4O. The easiest thing to do here is to just say that if 3M is equal to 4O, then 6M is equal to 8O. You are just doubling the equation. And then you can substitute this 8O with 6M. And so you'll notice that this basket is basically equivalent to 13 mangoes. And so that is what you would put here. That's the fourth basket with only mangoes. You would have 13 mangoes. And that is the answer. This thing, technically not necessary to know this, but is a very useful, powerful idea in certain other arithmetic questions. What you want to do is do the substitutions. You use the two equations to basically find, you could find A is to O is to M. Again, in this question, you did not need to explicitly write this down as 3 numbers. What would those numbers be? I would just put 3 and a 4 here. 3 into 4 is equal to 4 into 3. It balances. So O is 3 and M is 4. And if M is 4, A should be 8. So you can use the two equations to find the unknown ratio of 3 terms. As far as this particular question is concerned, you could bypass this explicit step and do another substitution and get the answer. But that's the concept that I believe they're intending to test here. Unknown ratio requires one less equation than the number of terms in that ratio. Very, very often tested concept in the arithmetic section, I've noticed. Anyway, that's question 5. We will move on to the last question in this video. 6. If the area of a regular hexagon is equal to the area of an equilateral triangle of side 12 cm, then the length in centimeter of each side of the hexagon is how much? Now there is the simple way of doing this with a little more writing, and there's a more efficient way which might be slightly harder to understand, but it's actually more efficient. Let's do the simple one first. What do we need? SIGs, I've given tags, similarity, polygons, the fact that a regular hexagon is basically 6 equilateral triangles stacked together around the same point. I suppose we could add area of equilateral triangle, area of regular hexagon as a third concept. So simple way is to just do exactly what they've written. Area of a regular hexagon is equal to the area of an equilateral triangle. So let's do the area of the equilateral triangle. It is root 3 by 4 side square. Side is given to us straight up. And then the other side you have a hexagon with an unknown side. We'll call S. We are trying to find that out. One of these 4 options. We know that the hexagon is 6 times, or you can directly invoke the formula. It's 6 root 3 by 4 side square. That's what we have. What do? We just cut the root 3 with the root 3 with the 4, the 4, the 6 with the 12, and you have a 2. So you have a side square is equal to 24. 24 is basically 4 into 6, right? So then S would be 4 will become 2, 6 will become root 6. That is all you need to do to solve this question. Now, if you want to be more efficient than that, what could you do? You could solve this paperless by just saying, if the hexagon had the same side, the area would be 6x. 6 times that of the triangle, right? That's what I mean, 6x. You can verbally reason this out. If the hexagon had the same side, area would be 6x. I want the area to scale down by a factor of 6, and for this I need the side to scale down by a factor of root 6. So then the answer would be the starting 12 divided by root 6, which is 2 root 6, which conceptually is a little tougher, but I think execution wise is faster than writing this down. As soon as you have an equation with two sides and denominators and stuff, you're forced onto paper. You could bypass all of that. You could just look at this and say, same side would be 6 times the area. I want it scaled down by area to be scaled down by a factor of 6 means side is scaled down by a factor of root 6, and so that's the answer. That is an alternative approach to it. You don't have to do it. This is good enough. I think this is slightly faster. See you in the next video.